Reagents in organic reactions can be classified as either electrophiles or nucleophiles depending on whether they attack the regions of high electron density or regions of low electron density. These are the most important concepts in organic chemistry. Electrophile is a positively charged or neutral species that are deficient in electrons, which is it lacks of electrons, and can accept a pair of electrons. It is also called as an electron-loving species. These are an example of electrophiles. The Lewis acid, which is the electron pair accepted, such as the cations, the carbocations, and also the incomplete octet molecules. An oxidizing agent such as the chlorine and bromine, also the polar molecules such as hydrogen chloride and hydrogen bromide. Electrophilic site is a molecule with low electron density around a polar bond. So this is a hotspot for electron to attack. For example, in carbonyl compound, the carbon that is attached to the double bond O, so this carbon is the electrophilic site since it is much more electropositive compared to the oxygen. Same goes to in haloalkane, the carbon that attached to the halogen group is said to be the electrophilic site. And in the hydroxyl compounds, the carbon that attached to the OH group is an electrophilic site. Nucleophile is a negatively charged or a neutral species that are rich in electrons and can donate a pair of electrons. It is also called as a nucleus-loving. The examples of nucleophile is a Lewis base, which is an electron donors such as an ions, carbanions, and also molecules with lone pair. Molecules that contain a pi bond between carbon atoms also can act as a nucleophile, such as an alkene. The reaction of organic compounds can be classified into four main types. We have the addition reaction, elimination, substitution, and rearrangement. In addition reaction, all parts of adding reagent will appear in the product. In this reaction, the two molecules, one of it is our organic molecules, will react with another molecules and become one. The reaction of addition reaction always involve the compounds with multiple bond. In this reaction, the double bond will become single bond. Addition reaction can be further classified as electrophilic addition and nucleophilic addition reaction. In electrophilic addition, the reaction involves the carbon-carbon double bond and carbon-carbon triple bond. In this reaction, the carbon-carbon double bond will be converted into carbon-carbon single bond and carbon-carbon triple bond will become carbon-carbon double bond. For example, here, if I have the carbon-carbon double bond compound, okay, so this is an alkene. Alright, so the carbon-carbon double bond act as nucleophile since it is rich of electrons, and the HBr molecules will act as an electrophile. Due to the addition of the electrophile into the carbon-carbon double bond, the reaction is an electrophilic addition reaction. Nucleophilic addition reaction is the most common reaction of aldehydes and ketones since aldehyde and ketones containing the carbonyl group, which is the C double bond O group. In nucleophilic addition, the C double bond O will become C single bond O. So in this reaction, aldehydes and ketones, the carbonyl group will act as an electrophile and the other molecules will act as a nucleophile. So the C double bond O, the carbon here is the electrophilic site, and this carbon will be attacked by the nucleophile. Since nucleophile is added to this compound, so this reaction is a nucleophilic addition reaction. In the elimination reaction, a single reactant will be split up to two products. So this reaction is a method to prepare compounds with double or triple bonds. So generally, this reaction will convert the carbon-carbon single bond into carbon-carbon double bond. So for example here, if I have an alcohol, Okay, if you notice here, all the bonding in the alcohol compound is a single bond. Okay, when it's reacted with sulfuric acid, concentrated sulfuric acid, and heated, it will be converted into an alkane, carbon-carbon double bond, and also water as our side product. So from the carbon-carbon single bond, when it's become carbon-carbon double bond, this reaction is said to be elimination reaction. Rearrangement reaction is a reaction in which atoms in a molecule are rearranged to form a new molecule. So in this reaction, the atoms and also the bonding in the molecules are the same, only the arrangement of the bonds and atoms might be differ. Substitution reaction is a reaction in which one atom or group of atoms replace another atom or group in a molecule. There are three types of substitution reaction. So we have free radical substitution, electrophilic aromatic substitution, and nucleophilic substitution reaction. In free radical substitution, it is most common reaction of alkanes or cycloalkanes. The conditions needed in this reaction is the presence of UV or sunlight. So, when an alkanes or cycloalkanes reacted with halogen, halogen molecules in the presence of UV or sunlight, it will be converted into haloalkanes. So the one that we substitute here is one of the hydrogen from the alkanes into halogens. In electrophilic aromatic substitution, this reaction involves all aromatic compounds. So for example here, if I have a benzene ring, my aromatic compound, so the reaction will occur at the benzene ring. Okay, so since you know that on the benzene ring, there are one hydrogen atom attached to each carbon, right? So we have one hydrogen atom attached to each carbon. So the one that we are going to substitute here is the hydrogen, okay, one of the hydrogen in the benzene ring with another electrophile. So in this case, okay, in our reaction here, the electrophile, the new electrophile that we substitute into the benzene ring is the bromine. Nucleophilic substitution reaction is a common reaction of alkyl halides and alcohol. So for example, here if I have an alkyl halide, okay, so the one that we are going to substitute in this reaction is the nucleophile. Okay, so in alkyl halide, okay, the carbon that attached to the halogen is an electrophilic site, while the halogen here, the Cl atom here is the nucleophilic site. So the nucleophile, the Cl atom, is going to be substituted with another new nucleophile, which is from sodium hydroxide. The nucleophile here is the OH minus, the hydroxide ion.